Hello everyone, I am Bindusree, working as an assistant professor in the Department of Electronics and Communication Engineering in the Institute of Aeronautical Engineering and Technology. So my subject is the high-speed communication. Today I am going to discuss about the M-ary modulation technique. So in this M-ary modulation technique is the multi-level digital modulation techniques. In this multi-level digital modulation techniques are the three types of the modulation techniques. One is the M-ary SK, another one is the M-ary FSK, and another one is the M-ary PSK. So today I am going to discuss about the M-ary FSK. So M-ary FSK is the multi-level frequency shift keying. It is the one type of the digital communication technique. So it transmits the multiple bits are simultaneously. So it is maintaining the proper carrier frequency to the group of the bits. So normally in the M-PSK is the multi-level amplitude shift keying. So that is the number of the bits are depending on the amplitude levels. So coming to the digital communication technique is depending on the FSK. So that is the multiple number of the bits are depending on the frequencies. That is the each and every bit is assigning the carrier frequency, unique carrier frequency. So in this carrier frequency is representing the different number of the symbols. So that are the bits. So it is same as the M-ary FSK. But in this M-ary SK, it is multiple number of the bits are depending on the amplitudes. So coming to the M-ary FSK, these multiple bits are depending on the frequency shifts. So here each and every bit is having the separate frequency values. So that frequencies are the successive frequency values. So it is taking the successive frequency values of the each and every bit. Next one is if the M-ary frequency shift keying is the efficient modulation. So here the total concentration on depending on the frequencies only, multiple level of the frequencies. So here for transmitting and the receiving the M-ary FSK, it is maintaining the low power and the low data rate for the data transmission equipment. So this is the M-ary FSK. So next one, if we are taking this one, any one M-ary signals are M equal to 2 power n. So n is the number of the bits, m is the number of the levels of that particular bits. For example, n equal to 2, so m equal to 2 power 2. So that is the 4 bits. Here n equal to 2 bits, the total M-ary is the 4. So that is the 4 level of the FSK. So in this one here we are taking the multiple number of the bits. So that M-FSK is the extension of the PFSK. So that is the binary phase shift keying. In the binary phase shift keying, bits are the only 2 bits, binary zeros and ones. So in this BFSK, for that 0 is the one frequency of the signal, for the 1 is another frequency of the signals. So coming to the M-FSK, so in extension of the BFSK, so here depending on the number of the bits, the levels also increase. So in this processing, it is taking the 1 bit at a time. So a unique carrier frequency is assigned to each possible groups of the n bits. So the transmitter is there and the receiver is there. In the transmitter side, transmit the signals. That signals are the M frequency based on that signals. It is a very efficient modulation scheme. It is used for this one. It maintaining the proper data rate as well as the low power. So the transmission of the number of the bits are equal to Ng duration. So the signal is representing by 1 by 2s h. So why? Because if the f equal to 1 by t, so here depending on the frequency values, so in terms of this one, if the ts equal to, so that means each and every signal time duration is the 2t seconds, so that is the 1 by 2 ts of h. So that frequency is the 1 by 2 ts h's, making the signals to orthogonal to each other. So the bandwidth efficiency of the M-ary FSK is decreases, so the power efficiency will be the increases. So when the level of the M value, so that means M value is the increases, automatically the power efficiency also increases. It transmits the multiple bits simultaneously. For example, we are taking the 4-array FSK. It groups of the bits into the pairs and assigning unique carrier frequency to each pair. So that means a 4-array FSK is 4-array FSK is, so here the M level is the 4. Here using the bits are the 2 bits. So the 2 bits are divided into the 4 combinations. That is the 4 level. Each and every symbol is having the different frequency. So this is the transmitter and the receiver of the block diagram. So coming to the transmitter block diagram, so the input bit is the input bit sequence B of t, and that input bits are given to the serial to parallel converter. So that means serial to parallel converter is the, so that serial bits are the combination of the all the input data. So that parallel bits, this B of t is including the all the bits. So when we are using the serial to parallel converter, so all the bits are separately. So that means B of t is divided into the B0, B1, B2. So multiple number of the bits. So for example, 1010 is there. So this is the serial bit of this one. So now converting to the parallel bit. So the B0 of the value is the 1, B1 is 0, B2 is again 1, and B3 is the 0. So here we are using the 4 bits only. Next one, N bit is the digital to analog converter. So here the input frequency is the, digital frequency. In the real time examples, obviously we are using the analog signals, but here we are taking the FSK, so that is the frequency shift keying. In this frequency shift keying, the input bits are the 1010, that is the digital data bits. So the digital data bits are converted to the parallel conversion. So that means each and every bit is given to the 1. So dividing to the each and every bit. So next one, N bit digital to analog converter. So that means the input is the digital one. So that will be converted in the form of the analog. So here it is depending on the frequency modulator. So that is the, depending on that signal is the frequency. So normally in the digital, if the signal is in the digital format only, so here we are having only zeros and ones. But when we are converting the signal to the analog signal, so each and every modulator, each and every signal is having the separate frequencies. So this is the frequency modulator. The output of this frequency modulator is the M-ary FSK signal. So one more is here the clock frequency is there at every TS seconds. So that means here this time period is the every TS seconds, means here it should be maintaining the proper periodic signal. That means if you are taking the any signal, the signal duration, if you are taking the any signal, so for example you are taking the square wave of the signal, so one positive and negative is there, so here it is maintaining the TS signal. So next TS seconds also maintaining the same waveform. So that is the periodic nature. So here the clock is, so each and every TS seconds the clock might be the changing. So this M-PSK signal transmitter diagram is like this. So this is the receiver one, block diagram of the M-ary FSK system. This is the receiver part. So this is the transmitter part, this one is the receiver part. Whatever the output value is presenting in the transmitter one, so that is the S of t. So that is the input of the receiver. So the output of the transmitter is equal to the input of the receiver. So that is the S of t. So here the output is the S of t, M-ary FSK signal. So coming to this part, so here we are taking the M-ary FSK signal. So that input is the S of t. So here we are taking the different band pass filters. Each and every band pass filter is having the one frequency of the signal. So that means M-ary FSK signal is having the combination of the signals. In the final output of the transmitter is again we are getting the combination of the bits output. So here M-ary FSK receiver input also the combination of the signal. So that will be dividing to the each and every frequencies. That means, so here the band pass filter at the F0. So for example, we are having the different frequencies. So that is the F0, F1, F2, so on Fn -1. So in the F0 is having the one band pass filter, and the F1 is the another band pass filter, for the F2 is the another band pass filter, for the F4 is the another band pass filter, up to the Fm-1 is the band pass filter. So here each and every band pass filter having the separate frequency values. Next one, that will be given to the envelope detector. That is given to the envelope detector. It is maintaining the proper amplitude levels. So next one, decision device selecting largest output. So here multiple number of the frequencies are given to the envelope detector. So each and every envelope detector is connected to the decision device selecting largest output. So here it will be deciding which frequency we are taking. So now in this block they are deciding to the particular frequency. So how can they are deciding the frequency? So that means based on this band pass filter, so which filter frequency is the high? What is the largest frequency value? The largest frequency value is given is selecting this box. For example, here F0 is there, F1 is there, F-1 is there. So for example, in this F1 is having the highest frequency level. So here first take the F1 value, F1 frequency. Next one, for example, F3 is there. So this is the highest frequency of the signal. So then selecting the F3. So now what is the largest frequency of the signal of this band pass filter? So by using this box we can select that particular highest frequency of the signal. So next one, that output is given to the n-bit analog to digital converter. So why we are taking the analog to digital filter? So coming to the transmitter block diagram, so before that one only digital to analog converter is there. So now the output is in the form of the analog signal. Now the output is the analog signal. So coming to the receiver part, in the receiver input also the analog signal. So based on this analog input only, so here we are selecting the frequencies. So based on that one we can select the largest frequency of the signal. If this envelope detector is maintaining the proper amplitude levels, and by using this decision device feedback output, largest output is, we can select the largest frequency of the value. So then select the another largest frequency. So then select the another largest frequency of the values. So coming to this one, so here we are having the it is concentrating only on the frequency of the signal, but that signal is in the form of the analog nature. That is the n-bit analog to digital converter. So that means here the input is the analog, again will be converted to the digital part. So each and every signal is divided into the digital part, same as it will be divided into the B0, B1. So it will be separate to the each and every bit of the signal. So then it will be given to the parallel to serial converter. Then it will be given to the parallel to serial converter. So that means in the parallel to serial converter, so that bit is that input bit is the parallel form. So that is the each and every binary value is separating. So then combining this all the bits, then we are getting the binary data sequence. So that is the parallel to serial converter. So finally we are getting the output is the binary data sequence. Here based on this decision box we will selecting that particular frequency of the value. So this is the M-ary FSK transmitter as well as the receiver block diagram. So already we discussed about the introduction part of the FSK. So it is one type of the digital modulation technique. It is used the more than the two distinct frequencies. So that means here we are selecting the multiple number of the bits. Automatically we can select the multiple frequencies. So it assumes each and every discrete values shifts the output frequency to set a predetermined discrete frequency levels. And modulator is the transmitter side, demodulator is the receiver side. So it is depending on the non-coherent demodulated signal that was modulated using the M-ary frequency shift keying method. So generally in the non-coherently method is not depending on the any reference levels or the any local oscillators. So here directly using the filters only. So in the receiver side, we are not using the any carrier frequency of the signal. So directly we are taking the band pass filters only. So one more is here the transmitter is completed, transmitter part is completed, and the receiver part is completed. So what about the bandwidth? What about the bandwidth of the M-PSK signal is? So for example, we are taking the one frequency. So this is the FC, and this one is the FC plus FL, and this one is the FC minus FL. So now we want to find the bandwidth of this M-PSK signal. So highest frequency signal minus lowest frequency, FC plus FL minus FC minus FL. So that means FC plus FL minus FC plus FL. So FC is cancelled. So this is the in terms of the cutoff frequency is the FC. So this FC minus and the signal frequency, that's what here we are writing FC minus FS and FC plus FS. So that is the FC plus FS minus FC minus FS. So here the two FS is there. So here the bandwidth equal to 2FS. Now converting the frequency to the time. So that is the F equal to 1 by D. So now we can write this one is 2 equal to 1 by Ts. Okay. So where Ts is the TB. So that is the 1 by TB. So this is the 2 into 2 power n by TB. So here we are using the multiple number of the levels. So that's what m equal to 2 power n. M equal to 2 power n. So generally based on this frequencies, that is the cutoff frequency is there, highest frequency is there, and the lowest frequency is there. So coming to this, our bandwidth is generally 2 into m into fs. 2 into m into fs. So that means 2 equal to 2 is the constant value. So where m is the, so in the M-ary levels, m equal to 2 power n. Where m equal to 2 power n. So based on the number of the bits, so we can select the multiple frequencies. So that is the 2 power n. Next one is the 1 by Ts. Where Ts equal to 1 by n into Tb. So that means 2 into 2 power n. So that is the, by using this formula, a into a power n is the 2 power n plus 1. 1 by. So here we are using the multiple number of the bits n into t. So that means based on this level, so we can selecting that particular frequency, if the n equal to 1 or 2. So based on this one, we can select this bits, and we can find that we can substituting that n value in this bandwidth one. So finally the bandwidth equal to, based on this one, 2 power n plus 1 by n into t. So if the n value equal to 2, if the n value equal to 1, so what happened? So 2 into 2 power 3 by 2 power 3 by TB. So that is the 8 by TB. So this value, so the bandwidth of the M-PSK signal is depending on this 1. So 2 power n plus 1 into 1 by n into TB. So the advantage of the M-ary FSK is the bandwidth efficiency is the increases. That means here we are taking the multiple number of the frequencies. For example, in the power spectral of this efficiencies, so this is the frequency of the signals. So these all are the lobes. So each and every values, it will be maintaining the constant time period. So that is the TS. So it bandwidth efficiency is the high data rates than the 2FSK. 2FSK means the BFSK. So the M-PSK is the extension of the BFSK. So the high data rate will be this BPSK. Compared to the BPSK, the bandwidth efficiency is more in the M-PSK. Next one is it will be maintaining the constant envelope. So this is another advantage. So it is using the multiple carrier amplitudes. So that is the each and every bit is maintaining the constant carrier amplitude. So Why? Because here it will be concentrating only on the frequency of the signal. Here it does not changing the any amplitude value. So that's what it maintain the constant carrier amplitude of the modulated signal. It is for using this one better to immunity to noise and the fading the channels. Next advantage is the nonlinear amplifier. So the signal is not proportional to the frequencies. It is used in the intermediate products. Next one is the noise immunity. So it will be performs well in the fadings and the interference of the signals. So these all are the advantages of the M-PSK. Next, coming to this disadvantages is the complexity and the bit error rate. For example, so what is the complexity is the multiple number of the bits. If you are taking the n number of the bits, so the FSK is maintaining the multiple number of the successive frequencies, and the bit error rate is if this any error will be occurred in this any one of that bit, automatically the frequency will be the changing. So that is the more complexity and the more error bit rate. So the M-ary modulation, M-ary FSK is totally depending on the frequency of the signals of the each and every bit. So depending on this formula m equal to 2 power n, so we can decide the level of the m. So these is the concepts of the M-ary FSK principles and the transmitter and the receiver and the bandwidth of this M-PSK and the advantages and disadvantages of the M-PSK. So M-ary ASK, M-ary FSK and M-ary PSK. So based on this one, M-ary ASK, it changes only on the amplitude. It does not change the frequency and phase. Coming to the M-PSK, it is depending on the only frequency. It does not depending on the amplitude as well as the frequency of the signals. Coming to the M-PSK, it is depending on the phase of that particular signal. It does not depending on the amplitude and frequency of the signals. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.